So for this lab, what we're going to do is we're going to create an AWS firewall and we're going to redirect traffic flow. And to begin explaining how we're going to do this lab, we're going to look at some examples from AWS. I'm going to click on a link here and it goes over the simple architecture that we have been doing in our labs throughout. Okay, and if you can look at this first diagram, what you'll see here is something you should be familiar with and what we've been doing, right? We've been creating a VPC, and inside of VPC, right, we have an availability zone with subnets, or in this example, it's just one subnet in a single availability zone. But how do we allow those objects or instances in our availability zone access to the internet? Well, we do it through an internet gateway. We create an internet gateway, we attach it to the VPC, and we set up a route table that basically says any IP address, right, that's destined for the internet, it's that quad zero we've been talking about, goes to the gateway. And so that's been the traffic flow that we've been using throughout our labs. And it's an example of a single zone architecture with an internet gateway. Now, if we want to add a firewall to the mix and redirect traffic flow, what we have to look at is this is an example with the same topology, only we're throwing a network firewall into the mix. And as you can see, traffic flow would have to be redirected. So what we would do is we would set up a firewall and we'd set up some rules on what we're going to permit and what we're going to deny. And so there's stateless firewalls and there's stateful firewalls, right? We're actually going to use stateless and stateful within the same firewall. And then subsequently, after those rules are created, we are going to create a firewall subnet. And the purpose of creating a firewall subnet is that the firewall is placed inside that subnet, and then the customer, any traffic destined for the internet does not go through the gateway. It goes through the firewall subnet first, where the packets are inspected. And if there's a pass or a permit, then traffic is to go to the internet gateway. Likewise, if traffic is coming into our VPC, right, through the internet gateway, then the internet gateway, if you look at the down arrow, instead of passing traffic directly to the customer subnet or the EC2 instances, traffic would have to pass through the firewall subnet first. And it's kind of explained in the diagram. Well, how do we redirect that traffic flow? Well, after we set up the firewall, we have to go back and edit those route tables. And that's what route tables are used for, right? Is to redirect traffic flow or to specify the traffic flow. And so we'll edit the route tables. And if we scroll down here, this is what the route tables are going to look like. So you'll have a route table for the internet gateway that says any traffic destined for, in this example, 10.0.2.0/24, right? And you have a target local, that's going to be changed, okay? The target is going to be what's called the VPC endpoint, which will be the firewall endpoint. And that gets to another question. Well, what is an endpoint? Well, an endpoint basically says that you don't have to have traffic leave your VPC if you want to access another internal AWS resource. So for an example, with an S3 bucket, if you wanted to access an S3 bucket through your VPC, without a VPC endpoint, it would have to go to the gateway, to the internet, and then back down to the S3 bucket, right? So you're actually having traffic leave the VPC, go out through the internet, back down through the internet, then to your S3. Well, with a VPC endpoint, we can just basically say that traffic will go from the customer subnet to the VPC endpoint, right? Which again is inside our VPC, and then back down to the customer subnet. So again, the purpose of VPC endpoints is so that traffic never has to leave your virtual private cloud when you want to access other AWS resources, and they could be S3 buckets or firewalls. Okay, so those route tables, like for the internet gateway, instead of local, right, which just sends it back down to the VPC, it first sends it to the firewall subnet. And then if you look at the original customer subnet here, right, and then we just have a local connection, which all devices can communicate with themselves locally, but any traffic destined to the internet goes through the gateway. We would revise that, okay, for the customer subnet. If you look at the customer subnet, notice what it says here for the quad 0, which represents the internet, send the traffic, that's the target, to VPCE 4114, which is the VPC endpoint for the firewall. And likewise, then the firewall would take any packet destined for the internet and send it to the gateway. And you still have those local routes. Okay, so again, that's a way of redirecting the traffic flow. So what we're going to do is go ahead and get started with the lab. And I'm going to pull up the notepad with our instructions. Some of this as a challenge you could try to do yourself. So you could actually go all the way and do these steps on your own if you feel comfortable with it. And I'm going to change this. We're going to use a Linux server, so we'll be using SSH and PuTTY. So let me save that. Okay. And so you could try to do it on your own, but if you're not totally comfortable with that, you can by all means, you could follow along with the video. But that's kind of a challenge, right? If you want to go ahead and give that a shot. If it doesn't work and you feel like you made some errors along the way, then you could just simply delete the subnets. And you would do that by first going to the route tables, removing the subnet associations. After you remove the subnet associations, you can delete the routes and you could delete the the EC2, and likewise finally delete the VPC and just start over again. So our first task is to create a virtual private cloud, and we're going to name it Firewall Lab, followed by your last name. So let's go ahead and get started. Now, as I noted before in the course, that you're going to have to use an AWS free tier account, and so you'll have to create one. Okay, here's the link below. It's rather a long link, but you can copy and paste that into your browser and create a free AWS account, which you would have access to the console. Now there's rules for a year, and I believe the limit is $100, but we're going to break down the lab when we're done in such a way that you're not charged. So after we create everything, we're going to quickly break it down. I've written the instructions in order as far as how you should break down the lab. Okay? So create your free AWS account, and after you create your free AWS account, you could proceed with the lab. So you could pause it, and then when you're ready to go, just click Start. Okay, so we're going to create a VPC and give it a name. So under the AWS free account, I'm going to click on VPC, select VPC, and we'll click on VPCs by region. Okay, now you may have a default VPC initially. Okay, I deleted mine. You could leave yours in there, that's fine. And so what I would recommend, don't worry about any default VPCs or other default subnets that you may have within your VPC. First step is to click on the Create VPC button, and we're going to make sure it reads VPC only, and we're going to give it a name. And again, I'm going to go back and forth referring to the notepad document. I'm just going to copy and paste the name, Firewall Lab Grillo, into the VPC. And we're going to paste it in there. Okay, we're going to use IPv4. Okay, the main seeder block for it is going to be the 10.0.0.0/16 that we've been using. Okay, now the /16 again, right? 8 bits per octet. There's 4 octets. So 16, that makes up 2 octets. That basically says the first 2 octets, 10.0, are the network portion of the address for the VPC. Okay, and make sure we got no IPv6 seeder block. Tennessee, we're going to leave as default, right? We're going to use virtualization and not use any dedicated resources in the AWS data center. So this is obviously the cheap route that we want to go. Tags has already been created, and from here just select create VPC. Okay, and if you click your VPCs at the top, your VPC has been created and it's available with the IPv4 seeder block. Okay, so that creates step 1, right? And then we go to step 2. We're going to create the public subnet, which is the customer subnet, and that's where our EC2 instance is going to reside. Okay, so we'll create that public subnet. We'll go on subnets. We'll select create subnet. Select your VPC. Make sure it's the one with your name and not the default VPC. And we'll give the subnet a name. We'll call it public dash EC2 dash subnet. Availability zone. So again, pay attention to the region. You're in the North Virginia region, right? So you're going to use, we're going to use US East 1A. And that's the default seeder block for the VPC that we created earlier. The IPv4 subnet seeder block is going to be 10.0.2.0/24, right? Which the 24 now says the first 3 octets represent the network portion of the address for this public subnet. And we can verify that address with the instructions here. That looks good. Okay, we've got our tag already created, and we're going to just select create subnet. Okay, so that creates the public subnet. Okay, next step, right? We're going to create a gateway, and we're going to attach it to the VPC. So we're going to set it up, make sure our EC2 works. It's just something that we've been doing throughout our labs. Okay, then we'll go back, and when we create the firewall, we'll edit the route tables. Okay, so we'll create our gateway. So we click on Internet Gateway. And we'll select Create Internet Gateway, and we'll give it a name. Call it your last name, -IGW for Internet Gateway. And select Create. Okay, so by default, right, when you create a gateway, it's detached from the VPC. And we want to connect it to our VPC. So what we do, notice up here in green, there's an attach to VPC button. We just want to select that. And we want to select our VPC. Again, make sure it isn't the default one. Make sure it's your VPC. And go ahead and click Attach Internet Gateway. Okay, so the gateway's attached, right? Okay, now we're going to create a public route table, right? And this is basically for the workload subnet, the customer subnet in which our EC2 resides. And we're going to say any traffic not in our routing table to go ahead and send it to the gateway. And then we need to associate that public subnet to the route table. So let's go ahead and do that. Let's click on route tables. You're given a default one, okay? Don't worry about that one, but that is actually our public route table. You can create your own and delete this one, but the easiest thing to do is in the name block, right? You see the pencil? Just click on it, and we can select public-route. I'll use RT for route table. and call it for EC2. Click Save. Okay, now what we want to do is, if you look at the routes at the bottom, we click on routes. Notice we got a local route, right? So what this means is you can communicate locally with any other object in your VPC with a destination of 10.0.0.0/16. Again, which is anything in your VPC. But what about routes to the internet, right? What if you're on an EC2 instance and have to access the internet? Well, you need to send it to your gateway, right? So the first thing you want to do is we want to click Edit Routes, and we want to click Add Route, and we want to use the quad 0 to represent any internet address. Click the drop down arrow and select Internet Gateway. Click in the IGW box and select the gateway with your last name, and then click Save Changes. Okay, so the last thing we have to do on this route is make the subnet association to the public subnet route, public subnet in which the EC2 instance is going to reside in. So we click on Subnet Associations. Should only be one subnet, right? So let's click Edit Subnet Associations. Put a check mark on the public EC2 subnet and select Save Associations. Okay, so that takes care of that. Okay, our next step is we're going to create an EC2. We're going to check that we have access to the internet, and we'll give it a name, something like Web Server Demo for Firewall. And we'll copy that name. We're going to use a Linux free tier instance. You're going to create a PPK key pair with your last name. We want to make sure that our EC2 instance is in the public subnet, and we want to auto assign a public IP. So we'll go ahead and do that. We'll click in the search, we'll click EC2. Click on EC2. We have no instances running, and we will select Launch Instance. Okay, now for name, I'll copy and paste that name that I copied earlier. It'll be called Web Server Demo for Firewall, maybe for Firewall Lab. Again, your names don't have to exactly match the names that I'm typing here. Okay. For the type of instance, we want to select the Amazon Linux server, and the image type we want to select is the free tier eligible, okay, which is 64-bit instance. And it gives you a description of that instance. The instance type, right, for the purposes of this lab, we would want a T2 micro. On a production instance, in a live network environment, you would probably want something like a T2 medium, okay, with 2 CPUs, and instead of 1 gigabyte of memory, you have 4 gigabytes of memory. Okay, now we're going to create a key pair. So we're going to click on Create New Key Pair, and we're going to give it a name, and I'll just type Grillo Key Pair. And we want to make sure we select PPK for use with PuTTY, and we're going to select Create a Key Pair. Okay, next step, and that downloads the private key that we will use to authenticate to the public key that's on the server. And then under Network Settings, we'll create Edit. We'll click on Edit. And make sure your VPC is selected, right? Make sure it's the VPC with your name on it. There's only one subnet, so that makes it easy. You want to place this instance in the public EC2 subnet. Auto assign public IP, we want to change that to enable, so it has a public IP address, okay? And then we're going to want to create a security group. So we're going to create a security group. We'll name it Firewall Security Group. And I'll explain. You may ask why we're creating a firewall. If we're creating a firewall, why do we need a security group on the instance? Well, those of you with a cybersecurity background who are going through the program know that there is a layered approach to security, right? You don't rely on a single point of failure in your network infrastructure. For whatever reason, if that firewall fails to do its job, right, then you have a second layer, a security group for your EC2 instances in your Amazon VPC. So again, a layered security approach. What is another layered approach? Well, on your servers, right, you have antivirus software. You have software-based firewalls that you can create on your server as well. So again, no single point of failure. Again, if the firewall fails, right, traffic passes through. For whatever reason, if the security group, if there isn't a match there, maybe you forgot to include something, right? There isn't a match, and if it passes through all the way down to the server or instance level, you could have a software-based firewall along with antivirus software on that instance. So again, you want a layered approach to security. So we're going to create a security group, and it's going to be named Firewall SG. We'll copy that. And so we're going to create a security group. We're going to change the name, paste it in, and you could use the same for the description as well. If you want to give the description a more in-depth name, that's fine. And then we're going to edit this inbound security rules. Okay, so first of all, for our inbound security rules, what we're going to say is we're going to allow SSH, HTTP, HTTPS, and the ICMP inbound to the instance from any IP address. Okay, now that's already included in our first rule, and so you have to click Add Security Group Rule. And then for type, for the second rule, we'll change that to all ICMP, IPv4, and the source custom will type source type is anywhere. Okay, we'll add a third rule, and for custom we change that to HTTP. Okay, source type is anywhere. And in the last rule, pay attention to the port numbers, right? There's no port numbers associated with ICMP, but if we go to add the fourth rule, we'll select HTTPS. Just need to find it. And HTTPS uses port 443, and we'll select any IP address. Okay, so those four rules are allowed, right? And just like anything else, there's an implicit deny with rules that say if there isn't a match, then the packet's supposed to be dropped. Okay, and so we got our four rules. We'll scroll down, and what we'll do, we've been typing the script ourselves in this box here in previous labs. We'll go old school and we'll kind of do it on the instance itself. Once we have access to the instance, we will go ahead and install the web server. We'll also install a text-based web browser so we can test internet access. Okay, and then from here, all you do is select Launch Instance. Okay, so we've created the security group. Our next step will connect the instance with the PPK private key on our workstation or laptop using the SSH client. Okay, now to access the instance, we'll have to use the PuTTY utility. You may have downloaded it already. I have it downloaded, but if you need to download PuTTY, just type in Google, download PuTTY, and it's the first hit you get from putty.org, and you click the download PuTTY here, And if you scroll down, you can use the putty.exe file, 64-bit x86. You can click on this link right here, which will download putty. It'll be placed in your downloads folder, and then you can access it from there. Okay? I think I asked you to do this in the previous lab, so it may already be on your laptop or workstation. Okay, so after you download putty, okay, let's go to our EC2 dashboard. Click on instances running. And before we go further, we got to make sure that our status checks have completed. So you want to make sure it reads 2 of 2 status checks have passed. Okay, so what I'll do is I'll pause the video momentarily while we're waiting for the status check to complete. Should only be another minute or two. Okay, so it was only actually about 30 seconds. So I guess I didn't need to pause the video. So once you see under the status checks that 2 of 2 checks are passed, we can begin by connecting to our instance. Now, what you want to do is you want to click on this instance ID right here, and you want to grab that public IPv4 address, and you want to click on it, and you want to copy it. Then you want to go to your putty utility. So on my Windows machine, I'll just type putty. And here it is right here. And you want to copy and paste that IP address. And then you want to connect your private key for authentication with the public key on the server. So click the plus mark next to SSH. It's hard to see. I know it's in small letters. Click the plus next to authentication. Click on credentials. Click on browse. And you'll have the Grillo key pair, PPK, that we created. And you got the date right here as well. So make sure you got the right one. And just double click on it. And then from here, click open. And then you want to click accept. Okay. And I'll maximize this window here. And so we want to select log on as EC2-user. Okay. And now you're logged into the EC2 instance. Okay, so here's where the script comes in. The first thing you want to do is switch to the root user account. You could type sudo space su, right? Again, the $ changes to a hash, letting you know you're in administrator mode versus just the EC2 user mode. And then from here, you have the script, right? So the first thing we want to do is we want to perform an update. If there's an update, Amazon, I think they update these images on a daily basis. So if you type DNF space -y space update, hit enter, right? Dependencies resolved, nothing to do, complete, right? The machine image is already updated. Okay, so what we want to do now is install the Apache web server, because we're going to be setting up a very basic website. Okay, so you can copy this command, dnf install http, and just right click and then hit the tab key. Enter. Okay, and you want to select Y for yes and hit enter. And let that run, and that installs the Apache web server software. Next step. Okay, so what we want to do is create a simple web page, right? So it's going to be really small. It's going to be called My Instance. If you want to add on to it, we can add on to it. I'll show you how. We'll copy it. We'll copy that command. We're doing it a command at a time this time. We'll go back to the instance. And let me type clear so we get back to the top of the page. And we'll just click and we'll hit enter. Okay, now if you wanted to view that file, you could type CAT space /var/www/HTML /index.html, right? And there you see the output. You could add on to it. Like, for example, if you wanted to add another paragraph, you could use your VI text editor, type VI space /var /www /HTML /index.html, right? And then from here, you go I for insert mode. And you could actually add another paragraph above it if you wanted to. So you can go make another tag with a P. And we can say, welcome to my firewall lab. I'm not very creative when it comes to names and creating websites. Okay, so I added that in there as well. Now, if you want to save it, hit the escape key. Okay, hold the shift key down, make the colon, and type WQ for write quit exclamation point. Okay. Next step. Okay, we're going to enable the web server and then start the web server. So it will be available upon reboot. We copy this command and we'll go click, hit enter. And then what you want to do is start the Apache web server. Copy it, click, and that installs the Apache web server. Now, what we want to do is install a text-based browser, right? And that text-based browser is called Lynx. It's not very functional, but it's good if you want to test internet connectivity. There are some Linux geeks or gurus or whatever you want to call them out there that everything's done from the command line, right? Even viewing web pages. But it's not a very user-friendly experience. We'll install Lynx. We'll type, let me Control Z that. Okay. We'll type DNF install with the space between DNF and install. And we'll type Lynx, hit enter, and we'll type Y for yes and hit enter. Okay, and that installs the web browser. Okay. Now, what you want to do, we want to test connectivity, right? Because now the way we've set it up is anything not in our routing table goes to our internet gateway, right? And so we will type www and just type Google. We got to type links first, LYNX space www.google.com. Hit enter. Okay, and it's not very functional. I mean, you're going to have to allow cookies 100 times. Look, it's keep asking us. I'm going to do that. Okay, until I had to do it like 3 times. And then you see what the Google page looks like in a web browser, right? You have your search and you have some links up there. Again, not very user-friendly, right? But it's a way of testing connectivity to the internet and to a website to make sure that you have access to websites. Now, if you want to exit links, just do a Control Z, and that takes you out of links. Okay, so we tested it. Let me expand this for a second. We'll go back to our instructions. Okay, now what we want to do is we want to begin the process of creating a firewall and creating stateful and stateless rules. But first, what we have to do, again, if we go back to the example I pointed out earlier in the simple zone architecture, we have to create this firewall subnet here in our VPC. And look at the address it's going to have. It's going to use a /28 with a 4.0 address. And the concept will be, instead of the customer going directly through the gateway, traffic will be passed from the customer subnet or the EC2 instance we were on through the firewall and then to the gateway. And the first step in that is to create the firewall subnet. Okay? And so what we want to do is, we're on this step right here, right? We want to create a firewall subnet with our last name, and that's going to be the associated subnet mask. So we'll go back to VPC, hit enter. We'll click on subnets and we'll go create a subnet. And I'm just going to copy and paste that name, firewall, subnet followed by your last name. We'll copy that. First thing you want to do is select your VPC. Again, make sure it's not the default VPC. It's the VPC with your name in there. Okay. And we'll give it a name. So we'll right click and we'll paste the name in there. It's going to be in the same availability zone, right? If you look at the diagram earlier, right? That firewall subnet is in the same availability zone as the customer subnet. That's the default IPv4 seeder block for the VPC. And the subnet for the firewall subnet is going to be 10.0.4.0/28. And I'll make sure I have that right. Right, so yes, that's correct. Okay, and then we'll just select create subnet. Okay, so there it is. And so our next step is to create a firewall. Now, the process of creating a firewall is you create your rules first, right? You don't have to. You could do it in any order. You can create the firewall, then create a policy, and then the rules, and then the rules, and then the policy. But what we're going to do first is create the rules. We're going to specify what's allowed in and what's allowed out, okay? And then we'll attach those rules to a policy. And then when we create the firewall, we'll attach the policy to the firewall, okay? So it's about creating an individual rules, individual policy, and when you create the policy, you'll attach the rules to the policy, right? And then when you create the firewall, you'll attach the policy to the firewall, okay? So the first thing to go over is we're going to create stateful and stateless rules. And what's the difference between the two? Some of you may already know, right? If you've cybersecurity and you've gone over firewalls or a network security class. So stateless rules are rather simple rules. They're less memory intensive in that, but they could at the same time make traffic flow a little bit more difficult because they examine each packet individually. So let's just say there's a stream of packets, and let's just say they're echo requests. And you create a rule for ICMP, for ping, or these echo requests. Each rule would be looked at individually, okay, with stateless. So the first packet is accepted. The second packet is looked at as accepted. The third packet is looked at, it's accepted, and so forth, right? Stateful looks at the whole data stream. And stateful rules can actually learn and detect suspicious traffic. So if there's a stream of suspicious ICMP echo requests coming in, not only it blocks the first rules and it just blocks the whole stream, right? And then it subsequently learns if that same stream were to come back in again. So it kind of memorizes it. I've given the example in the past that, if you have a very famous club in New York, right, where I'm from, and all the, actors and actresses and famous people go to the club and, right, they can walk in and walk out, right? The bouncer's not going to check. They already know who they are. They can come and go as free as they want, right? It's like a stream. It's not checked every time they leave or enter, right? But if somebody like me were to enter the club, right, they'd have to make sure that I was permitted. And let's just say for some reason I'm allowed access to that club. If I were to leave, let's just say I left my phone in my car, I leave the club, right? And I go to my car, I get my phone, and I want to go back into the club. They're not going to remember who I am, right? I'm just John Grillo, right? I'm not Brad Pitt or some famous actress, right? They're going to check my credentials again. So I'm the example of a stateless firewall, and somebody like a famous actor or actress would be an example of a stateful firewall. Okay? And so what we're going to do is actually create stateful rules and stateless rules. You can use them interchangeably. And you can actually say your stateless rules, once they're checked, anything else is passed to the stateful rule group. Okay, so those two policies can work together with each other, stateful and stateless. Okay, so what we're going to do, and we're on this step right here. Okay, we're going to create a stateful rule group, and we're going to block access to a few websites by domain name. Okay, and to do that, under firewalls, you go to network firewall here on the left, right? And you don't want to click on firewalls. That's to create the firewall itself. Firewall policies to create the policy. But remember what I said, we're going to create the rules first. So we're going to click on network firewall rule groups. Okay. And then if you look at the instructions, okay, we're going to, first step is to create a stateful rule group and block access to a few websites. So we're going to type in create a rule group, and we want to make sure stateful is selected. Okay, so we, again, stateful rule group. The rule group format we want to specify, okay, I'll go over each of these. We can create stateful rule groups by source and destination, IP address, ports, protocol, and other rule options like we've been doing. You can specify a list of domain names that are permitted or denied access. And there's this other rule called suricata compatible rule string, which I'll give you some examples of what they look like. Examples of stateful rules, and some of these, this is how you would use a suricata rule string. And you can go to this site right here. I'll actually copy and paste it in the instructions. I'll do it at the bottom here. So you can get an idea how you can use suricata rule groups. And there's different options here, right? For stateful rules, how you can block traffic. So if you wanted to add a rule here, and there's examples, you can just copy it, right? And then after you copy it, you could specify the suricata rule group and then just copy that string in there. Okay, we're going to specify domain list. And you have two types. You have strict order or action order. Okay, strict order, they say it's recommended and processed in the order that you define. The problem is remember, there's an implicit deny when there's not a match, or if there's a match. And if you use a strict order, you got to make sure your rules are in order. If you use action order, if you look at the explanation, you don't have to worry about the order. Say rules with a pass action. So packets that are permitted are processed first, then followed by the drop or reject or alert actions. Okay, so we're going to select action order, and then we're going to select next, and we're going to give it a name. And let's see, was there a name we were to give it? No, I didn't specify a name here, but we'll call it Grillo stateful domain dash block. Something that makes sense, right? Because we're gonna block access to a few domain websites, and we're gonna click it as paste text. Now, capacity, the number of rules you expect to have in this rule during its lifetime. you have no idea of knowing, right? So depending on the size of your organization, if it was a large organization, I would give it the max equal to one and no less than 30,000. So I'd give it 30,000. If it's a small to medium organization, I would type 2,000 in here because you're going to add on to your rule groups as time passes by, and you're going to click next. And then you're going to list the domain names. Okay, so the first one we'll type, let's just say we don't want to allow access to www.facebook.com. Hit enter. www. Let's just type KSAT. They're always inaccurate with the weather, so we're going to block them. I'm just kidding, right? Some of you may work there. Okay, so we're going to block access to the case. It's just for testing and to test it. And then, if you know some bad websites out there that you don't want people accessing, right? www, make up a fictitious one, evil.com, www.badboy.com, sites that you don't want people going to at work. Okay, so you can list some domain names in here, and we'll use the default custom CEDAR range, both for HTTPS and HTTP. So we want to make sure both of those are checked, and the action, we want to deny access. And then you click next. Okay, your data is encrypted. Choose a different key. We'll just leave that as is because it's encrypted by default. Click next. We won't add a tag. Click next. And we can verify that with our domains and click create rule group. Okay, so we created our first rule group. Okay. Next step, right? We create this. Now what we want to do is create a stateless rule group for ICMP traffic. Okay. So we will do that, and we will create a rule group. And we want to select stateless and select next. Okay, and then what we want to say, we'll give it a name, allow ICMP, use a dash in there, stateless, Grillo, and you could copy that and for the description as well. And again, for capacity, right, 2,000 should do fine. Click next. And then you want to give it a priority, right? So the ones with the lower priority are evaluated first. So you want to leave yourself some room for error, because later down the road, you may want to add another stateless rule in which has a priority that's higher, right? So, but you have to give the priority number higher. So if we give it a priority of 10, and then later on we want to add another stateless rule for whatever, DNS or TFTP, which is a file server, for example, access to that TFTP server, and it's a rule that's actually processed a lot, we would want to give it a lower priority. So the ones that generate the most traffic should have the ones that have the lower priority, and the rare traffic that you get, right, should have the highest priority. So we'll choose the protocol, take off all protocols, so uncheck it, and we want to select ICMP. Okay, you could select other ones if you want. Okay, so ICMP, there's UDP in here. UDP again is used, like TFTP uses UDP, and if you needed to back up large files, you could be denied or permitted based on the firewall rule. So we'll just leave it as ICMP. And the source we want to specify is everything in our subnet. So we want everything in our VPC. 10.0.0/16. Okay. And destination will be any IP address. And the rule action will be to pass. And you can add additional rules if you want. And then from here, you'd click next. Oh, I got to click add rule. Okay. Okay, so you got your one rule in here. Then you click next. And click next again. And click next. Just examine the rule and then the priority number. And select create rule group. So we actually have two rules, right? We have a stateless and a stateful rule. Next step, right, is we want to pull up our firewall. And now we want to create a policy and attach it to the firewall. So we're going to create a policy, and the policy says if you got connections broken in midstream, right, fragmented packets, and just connections are broken, then you just want to choose to drop connections, right, for anything that's broken in half, so to speak. So we're going to create a policy, and we're going to go back to the network firewall, and we're going to click on firewall policies here on the left. Okay, and we're going to create, and we're going to give it a name. Type Grillo-firewall-policy. Copy and paste. Okay, so again, the stream exception policy. Choose how the network firewall handles traffic when a network connection breaks in midstream. So we would want to drop all subsequent traffic going to the firewall. So if there was a connection broken midstream, whether it's TCP or UDP, those connections would have to be reestablished. Click next. Okay, we want to use the same actions for all packets. And what we want to do, how to handle a packet that matches the rules, matches criteria for the stateful rule groups, which means that under the stateless policy, it can kind of look at the whole stream when examining packets that are coming to and leaving the firewall. And we want to click add. Okay, we want to add the stateless. Okay, for the stateful rule evaluation, we want action order. Okay, we want to forward again. So for the stateless, we want to forward to stateful. And then for stateless, we want to select action order. And then we want to add that stateful rule group. Okay, and then we're going to click next. And we're going to click next. And we're going to click next. And for firewall policies detail, stream exception policies, the drop for stateless, actions for full packets for the stateful rule groups, stateless rule groups. Again, we're allowing ICMP. And then we want to scroll down and we want to select create firewall policy. Okay, so we create the rule groups and we attach the rule groups to the policy. Our last step is to create the firewall. Okay, so we're right here. We want to create the firewall and attach the policy to the firewall. Okay, next step, under network firewall, we're going to choose firewalls. And we're going to select create firewall. We're going to give it a name, call it Grillo Firewall. Let's copy that in the description. Click Next. Choose the VPC. Again, make sure it's your VPC and not the default VPC. You want to see, and now you're going to place it in the subnet. Remember, we created that firewall subnet. So availability zone is US East 1A, and the subnet is the firewall subnet, right? Not the public EC2. And for address type, it's IPv4. And then we're going to click Next. Okay. Now, in the real world, we would want to enable the deletion protection, right? I'm going to take that off, and subnet change protection. It's going to make it easier when we break down the lab, but in the real world, we want to make sure that those are checked. And click Next. And now we want to attach a firewall policy. So you want to select Associate an existing firewall policy. Click the drop-down arrow and select Grillo Firewall Policy and click Next. Click Next. Okay, you got your associated VPC, and it's in the firewall subnet, and select Create Firewall. Okay, now the firewall status is in provisioning. It's going to take a few minutes for that firewall to become ready. So I'm going to pause the video while we're waiting for the provisioning status to end. Okay, so it took about 5 minutes or so, and the firewall status is ready. Our next step is, again, to edit the routes so we can redirect traffic for all outbound traffic coming from the EC2 to pass through the firewall first, and then to the gateway. And likewise, when the gateway passes down traffic from the internet, instead of sending it directly to the EC2 subnet, it passes traffic through the firewall subnet, and then down to the EC2. So that way all incoming and outgoing packets are inspected by the firewall, right, before either leaving the VPC or coming down into the EC2 in which that subnet in which it resides in. Okay. Okay, now before we do that, I want to show you something, right? Our first step is we're going to create a route table for the gateway, and to create a separate route table for the gateway itself, something we haven't done is to make an edge association for the gateway. Show you how to do that. It's not hard. We'll click Edit Gate. We'll edit the routes. We'll add the gateway load balancer for the firewall endpoint. So this way the gateway will forward all incoming 10.0.0.16 traffic, which is our VPC, to the firewall, right? And again, not to the subnet in which the EC2 resides in. Okay, now the firewall endpoint, when we created the firewall, it created an endpoint. I explained again what endpoints are. And in the left here, if you click on endpoints, you'll see your endpoint ID for your firewall, right? It'll start with VP, CE, followed by a long string of numbers, okay? But you only have one in there, and the status is available, okay? So with that said, we can go ahead and start creating our routes or editing our routes. So again, we'll create a route for the gateway. So we have to go to Route Tables, and we have to go to Create Route Table, and we have to give it a name. We have to call IGW RT. Oops, try that again. IGW-RT, which stands for Internet Gateway Route Table. Select your VPC. Again, make sure it's not the default VPC. And select Create Route Table. Okay. So what do we have to do, right? We have to specify that this route table belongs to the actual gateway, right? That internet gateway that we created. So we have to make an edge association. So it's not a subnet association in this case because it's for the gateway. We click on edge association, okay? And you want to click edit. and you want to place a check mark on that internet gateway. Okay, and then you want to click Save Changes. Okay, and so if you click Edge Associations, it should be there now and it should be attached. Okay, next step. I'm going back to the instructions here, right? We're going to edit the routes and we're going to add the firewall endpoint, right, as the destination for all incoming traffic going into the virtual private cloud must go through the firewall first. Okay? So we'll click Edit Routes. And if the destination is 10.0.0/16, okay, the target, you want to select Gateway Load Balancer Endpoint, and it should be your Grillo firewall. Okay, and then you want to click Save Changes. Okay, so again, you're the gateway, you're the entryway to the internet. Incoming packets that are destined for the virtual private cloud anywhere, the target is the firewall endpoint. Okay, so that creates that. Now we want to create a route table for the firewall, associate the firewall subnet to the route table, and say for default routes, right, the firewall will pass traffic to the gateway. Any packets destined for the internet will go to the gateway. So again, we're going to go back to route tables. Okay, and we're going to go create route table. And what name did I say we were going to give it? Oh, I didn't specify a name. So we'll just call it Firewall RT. Firewall-RT. And the VPC, make sure you select your VPC, not the default. Select Create Route Table. Associate the firewall subnet to the firewall route table. Oh, not Edge Association. Click on Subnet Association. Click Edit Subnet Association. And add the firewall subnet. Again, make sure it's 10.0.4.0/28. Okay? And then you're going to add a route. All right, so as you can see here, we'll add the quad 0, which is routes to the internet, will pass through the internet gateway. So we'll click Edit Routes. We'll click Add Route. And we'll say the quad 0, target, internet gateway. Click on IGW dash and select the internet gateway you created and click Save Changes. Okay, almost there, right? Now we have to specify in the public route table, right? We have to tell anything in the 10.0.2.0/24 subnet, okay, we'll have to change the default route from the gateway to the firewall endpoint. So again, we'll click on Route Tables, and we'll click on the public route table. And we want to change this destination, right? So that way, the EC2 instance, the target for traffic destined for the internet, will be the firewall endpoint. So you have to click on Edit Routes, go to that quad 0 route, and we're going to want to change it from internet gateway to gateway load balancer endpoint. And you'll see a VPCE dash, and there's only one endpoint we created, which is our firewall, and you click Save Changes. Okay? Okay, so that pretty much completes the lab. What we'll do is we'll test the functionality of the firewall. So for example, if we go back to our EC2, right? So if we type www Sometimes I have to log out of here again and log back in. Close it. I'm gonna have to back in. Okay, no problem, right? So we just go back to putty. No, it's not in here. Type Putty. Oh, not here. Okay, I am definitely doing this the wrong way. Should type putty here. Putty. You know what? I got it in my downloads folder. Here's putty. It's actually last week's putty, so I go ahead and click on that. I can close that window. Okay, so what I need to do is go back to the EC2 and grab that public IP again. Click on instances running. Click on the instance ID. Copy the public IPv4 address. Go back to putty. Paste in the IP address under host name or IP. Again, click the plus sign next to SSH. Click the plus sign next to AUTH. Click on credentials. Click browse. And copy your private key. Open. Type EC2-user. Hit enter. And you're logged back into the EC2. And if you type links, www.amazon.com. Okay, again, you get a bunch of cookies. If you hit Y a few times, that's 3 times, that's 4 times. Okay, there's the Amazon website, right? So if you want to buy anything, good luck trying to buy something on a text-based browser. But that's how it looks like, right? So, sneakers, etc. So you could do a Control Z. Now if you type links, ksat.com, you'll get nothing, right? Because KSAT is being blocked by the firewall. Okay, so you have no access to ksat.com. Another one was facebook.com, so you want to test that. Links, www.facebook.com. Okay, again, so you're not allowing traffic to come back into the VPC into your subnet, which EC2 resides. Okay, so traffic is being blocked from Facebook.com, but we allowed Google. We didn't block Google, I don't believe. We typed Google.com again. And then again, here we go with the Y's, right? Allowing cookies, got to do it 3 times. And then you're into the Google website. So you get to see how the firewall works. If you type like wget, www.google.com, say we want to grab the IP address. Okay. It resolves it into an IP. So if you see the IP address in there, you can type ping 172.253.63.106. Hit enter, and you're getting your echo replies because we're allowing echo ICMP traffic to pass through. Okay, so again, that's a demonstration of the firewall, and that pretty much completes the lab, but we need to break it down. So don't quit yet because there's a process we need to go through. And just hit exit twice to exit out of your putty session. All right, so I actually written down the instructions for how to break this lab. Okay, the first thing we want to do is delete all subnet associations in the routing table. Okay, so we got to go back to our routes. So we got to go to EC2. And then the left, where am I at? Oh, VPC, I'm sorry. We go back to VPC, not EC2. And we want to go on route tables. Okay, let's click on the public route table. Click on subnet associations. Click edit. And we want to take off that X mark here where it says selected subnets, and there's an click on that so there's nothing checked, and go save associations. Okay, so that's the public subnet. And go back to route tables again. Click on the firewall subnet, right? So make sure you're on the firewall route table, excuse me. Go to subnet associations, click edit subnet associations, click on the X to take off the check mark, and go save associations. And then click on route table again, go to the gateway. Now you want to take off the edge association, so you click edit, take off the check mark, and go save. Okay, so there should be no edge association. So that's step one. Okay, you know what? There's probably a faster way of doing this, but it's like this algorithm that I haven't been able to figure out yet for how to actually break down a lab. But I know this way works. So next step is to delete the EC2. So we'll go to EC2. And we got one instance running. Click on it. And under actions, instance state, we want to terminate, delete the instance. Okay, and it should be shutting down. And it'll take a while for it to be terminated. We may have to wait. May not allow us to do some of the other stuff. Okay, so we've done step 2. And then we want to detach and delete the gateway that we created. So we go back to VPC. Did I close that WordPad window? Yep, I did. Notepad. It's actually in my Notepad's actually up here. There we go. Yep, here we go. So we're breaking everything down here. So we're going to detach and delete the gateway. So you're going to go to your gateway. Should be under VPC. Go to Internet Gateway. Click on it. See if I can do it from here under the actions. Yep, detach from VPC. So you put a check mark on it, and under actions, let's try that again. And we click detach it, click on it, and then we'll go delete Internet Gateway. And then you got to confirm it by typing delete. And want to make sure you really want to delete it. Okay, now what we want to do is we want to delete the firewall route table and then the gateway route table. So we go to route tables. Click on firewall route table. Go delete route table. Click on the gateway route table. Select delete route table. And we go to our next step. One thing I wanted to show you to do, it's really easy. I forgot to create the S3 bucket, and you can go back and repeat this lab. When you create the firewall, there's an option there for logging, like matches with the firewall, whether the permit or deny matches, right? These log files are created. You can have them actually sent to an S3 bucket, right? And so what you would do is just create an S3 bucket. That's all you need to do is give it a name and click create, and then put a check mark. When you click on logging, click edit, and select that you want logging, and then you're going to select the object, and you're going to select S3, and you're going to use your bucket name that you created. There's no drop down arrow, so you got to copy and paste your S3 bucket name to that. But that's really simple, and I encourage you to try to give it a shot yourself. So again, you create a bucket, copy the name, okay, go to the firewall, click edit, under edit, right? Then you want to, for logging, you want to click edit. And then for logging, you want to specify yes, and then you want to specify that the log files will be sent to an S3 bucket, and then you're going to copy and paste that name in the window, and that's all you need to do. And then you can go back to that S3 bucket and see the files in there that you actually created. Okay, and if you do that, there's a step in here to delete the S3. So you got to delete all the objects in the S3, okay, and then delete the S3, and then you would turn off the log alert in the firewall, okay, and that's part of the steps, but we didn't actually do that. Okay, so we've done the gateway, and we want to now delete the default route in the public route table. So we click on the public route table, click edit routes, and that default route that we have to the quad 0, just remove that one and click Save Changes. And now we want to finally delete the workload subnet or the customer subnet. So we click on subnets, and we want to click on the public EC2 subnet. And under actions, we want to delete the subnet, and we want to confirm it with a delete. Okay, we didn't create the S3, so we can kind of skip all that. Okay, our next step is to delete the firewall. So you're going to go to the firewall. Click on Grillo Firewall and select delete. And you're going to confirm that. Okay, now while it takes a little bit for the firewall to be deleted, and because of that, it can take several 5 minutes for the firewall deletion to finish, okay? So you click on firewall policies, click on firewalls, okay? You still have the Grillo firewall. You see it's in the process of being deleted. So I'll pause the video. It should only take 5 minutes or so for it to be deleted. Okay, the firewall is actually deleted, and you can tell if you hit refresh and you get this screen again to tell you to create one, it means you don't have one. So it successfully deleted the firewall. And now you want to delete the firewall policy and the rule groups. Now that the firewall is gone, there's no policy, the policy is not attached to anything. You can delete it. See, you can't just do this in any order because you'll get all kinds of errors, like deleting the rule groups. They'll say you can, it's attached to a firewall, and then it's attached to a gateway, and it's attached to an endpoint. And then we go to the rule groups, and we'll delete both of those. Okay, so that completes that step. And what I would do is I'd encourage you to redo this lab and experiment with the firewall and add more rules in there. and learn how to test the functionality of your VPC. So again, the advantages of the free account is as long as you keep these breakdown instructions, then you shouldn't be charged anything. Okay, so the last step is delete the firewall subnet and then delete the VPC. So let's click on endpoints. Okay, there's no endpoint in there. Good, the VPC's endpoint is gone. I mean, the firewall endpoint is gone. So we'll delete the firewall subnet. Type delete. Again, save these breakdown instructions and then click the firewall VPC. I mean, click your VPC, right? Which is our lab VPC. And again, we can go actions and we could select delete VPC. Try that again. Actions, delete VPC. You can leave your default one in there. That's okay. And just click delete. And it's gone. Okay, so again, that's pretty much the lab. I created that link to show you how to create the free account and also how to look at some Suricata examples. You can use Google searches as well. But I encourage you to go through the lab again and experiment with the firewall. Now, again, I forgot to show you how to create the logging, but again, like I said, just create an S3 bucket with a name and copy the name, right? That's all you got to do with the S3. And then when you create the firewall, as you're clicking next, there's a screen there that says logging. Just click edit and select you want logging via the S3 and then copy and paste the bucket name in there. Okay? And then after you tested the firewall, you can go to your S3 bucket and actually see the log files that are created from there. Okay, this concludes the lab.